So I'll go on to presentation. The whole presentation will be done in QGIS for the activities, as well as easily go through the whole process. So this is what we have for the area of interest, and I'll go through a brief background about the area and why we're interested in developing this particular area. Please maybe continue on.
Can we, sorry to interrupt, can you hear me? Chimango, can you hear me? I'm just checking. Your sound is not great.
Your sound is not great.
Okay.
I'm not sure.
Okay.
Okay.
My perception is very small. I hope I'm not going to switch. I'm going to switch from the other.
Okay.
Okay.
All right. Yeah. We're just waiting for Chimango to sort of rejoin us with slightly better audio so we can hear better, although this mapping looks fantastic. So I'm really interested to see what happens, and then we'll see. The audio you're speaking with is currently muted.
Can you hear me now?
I can hear you. It's still, the audio sounds like just weird. I can't explain.
How about now?
Yeah, I can hear you a little bit better.
Okay, great. Okay. So I'm going to share my screen now. Please, if you can see my screen.
I can find, like, it's like your microphone's picking up on the background noise more than the noise, like your voice. So your voice is being clipped out, but the background noise is being heard, if that makes sense.
How about now?
Oh, there we go. Perfect. I can hear you perfectly.
Okay, great.
Awesome.
Okay. So can you see my screen also?
Yes. Yes.
Perfect. So I'll give a brief background on the area of interest.
Mm-hmm.
This is Manchewe watershed in northern Malawi, Rumpi, and as if some of you are frequent travelers, you might have heard of Manchewe Falls. It's a very scenic place, and it's characterized by several caves behind the waterfall, so it's quite beautiful. Also, the area in the middle here is Livingstonia. I'll just, for context sake, I'll just put up the OSM base map. So Livingstonia is TPE, Topographical Planning Area, initially run by the Presbyterian missionaries who settled here and built schools and hospitals to cater for the surrounding area. So north of Livingstonia is Karonga district, which is one of the northern districts in Malawi, and Livingstonia is in Rupi district. So I thought I would prioritize the topographical description of the area and explain how I'll go about generating some of the data. So for heights purposes, the area, I delineated contours for the area to visualize the terrain in a 2D manner. So as you can see, the watershed was delineated in a triangular fashion, the methods of which I will not go in depth, but for context, water is flowing from the direction that my cursor is, going eastwards, northeastwards to Lake Malawi. I don't know if I'm still clear. Just let me know.
Absolutely. No stress. I'm hearing you loud and clear.
Perfect. So this was part of my research while I was with University of Livingstonia, and the data was submitted to the Environmental Management Department. And currently, there is an initiative for water quality mapping for the whole country. So this is part of the data set that we're going to upload to an integrated system monitoring everything. So initially, I classified the data from the sample points, which were collected using standard methods and procedures for 3 different uses: ecological, water quality, aquaculture, drinking and drinking, aquaculture and drinking. However, the domestic or drinking water quality samples were also flagged as irrigation water samples because there's gardens near some of the areas where the samples were collected. The domestic water samples were collected. So having collected these samples, several parameters were analyzed using standard procedures as well in a laboratory setting. Of course, some of the data was collected from in situ measurements, like on-site measurements, where you notice things like the pH of the water, dissolved oxygen, and as well as the turbidity and other parameters that are of interest. So the data was collected using a GPS receiver and transferred in GPX format. The process of which I won't go through in this session because it involves another software called Basecamp by Garmin. Upon transferring the sample locations from the GPS receiver, the data was converted to the versatile shapefile format, the GIS format, to plot it in this fashion. So, of course, there were some statistical analysis, both descriptive and inferential statistics, which also led us to derive the current data we have here. So, for context, the data that was collected, the samples that were collected, have the data which I will visualize in the following attribute table from the GIS, from the GIS software. Okay, hydrogeology. So I'm going to show you an attribute table which will just visualize how this is in the fashion in which the samples were collected. So we have a sample point name, the latitude and longitude, and the various parameters, which we have as derivatives of the sample exercises. However, drinking water quality or domestic water quality is different from ecological water quality, as it is different from aquaculture and irrigation water quality, because of the different uses and the different interactions that the water has with its use. There's different parameters of interest. So for that, we have a separate data set, which is the one we plotted here, which now contains basic parameters that are homogeneous across the water samples. So these are more like the physical parameters, and I only chose 3 parameters for an analysis of the physical conditions. Through this session, I'll also describe how some visualizations were made, including profiles, to show you the interactions of certain elemental properties, like certain rock interactions and the implications of the water quality. So for context, the 3 plugins we'll use as part of the workflow are Dataplotly, Stack API, browser, and QProf. These are all QGIS plugins, which proved to be very instrumental in this study. I don't know if we're still in the clear, if we're still following.
Yeah, I actually had a question there. I'm quite interested in water quality myself.
Okay.
And those 3, obviously pH is quite clear. Is EC E. coli? What were the other 2 parameters?
No. That's a good question indeed. EC is not E. coli, and EC represents electrical conductivity.
Okay.
Yeah. There's a different parameter called the fecal coliform parameter, which now is the count of bacteria. It's fecal bacteria found in water. However, I'm not going to report to visualize that data during this session. I'm going to focus on the physical parameters, which in this case are EC, NTU, which is nephelometric turbidity units, and pH.
Cool.
So, yeah. Thank you. That was a very insightful question. I don't know if anybody else has a question before I move on, so that we can be on the same page.
If anyone in the room has a question, please feel free to come on mic. And then there are a couple of people on YouTube Live, San, Kuku, and Alfred Manda, who have all joined in, and they were just saying hi on the live stream. So thank you to everyone who's joined us today. Alrighty, Chimango, carry on.
Perfect. Moving on, I'll now plot some of the final derivatives we have in the end, and now simply rapidly explain how I managed to derive those. So, for the sake of, I'll start with the topographical aspects. I'll remove the OSM base map and visualize. Oh, this is now a DEM, which was obtained from JAXA, Japanese Astronomical Association, if I have the name correct. It's the 30-meter resolution digital elevation model that basically is representative of the height. And from I think from the range of the DEM, which covers a larger area, including parts of Lake Malawi, ranges from 455 meters ASL to 2,379 meters ASL. So the DEM visualizers also was very instrumental to creating the profiles. But for the sake of visualizations, I preferred to use the hillshade because it blends well with most of other components. So that's the topography, and those are the contours. It was actually established that there is both the contours, the DEM, as well as some data, the data I collected, or the altitude data I collected during the sampling exercise, were actually the same, and the data actually agrees. So you can tell that both the DEM as well as the contours, which were obtained from Malawi surveys, make similar sense and can are quite reliable data. JAXA is open data. The Malawi survey data isn't open data. I had to access it with permission from the office. However, the sample points I have collected are also not public data because the data belongs to the people who manage the drinking water system, the distribution network. So I was just fortunate that I got permission to share the analysis with you, but the data isn't open. So this here is a river, as I said, that courses eastwards towards the lake. And from the topographic map here, you can see a density of the contour lines here at sample point number 2. This is where the falls is, and there's cliff that goes down, and water goes on to Lake Malawi. This part here in the middle is a plateau, and this part here, as you can see from the density of the contours, is actually an escarpment connecting to Nyika National Park, going eastwards. Going westwards. So, so the area in between the river is the lowland that allows for water flow downstream. That's the topography, and fortunately, it will be overlaying the information with the other data. Now I'll move on to hydrogeology, and I'll plot the watershed hydrogeology, which I acquired from British Geological Survey. They have an extensive map of the hydrogeological map of the globe, including Malawi. So yeah, this is what I used for the overlaying of the data. I acquired this data from British Geological Survey to visualize the groundwater systems here. So the area is characterized by 2 aquifers. Please pardon this cartographic mess here. I'll just remove this the DEM for the sake of the colors. So the dotted region is a fractured basement aquifer, and the hashed crisscross area is a quaternary aquifer. I won't go in depth about the differences between the two in the interest of time. However, the fractured basement aquifer data collaborates with some of the discontinuity geological data that's in the area as well, where there's faults in some areas where water goes out of the host rock. So this will actually collaborate with the geological data to show us the relationship between the water flow and the fluid dynamics of the water. So yeah, that's on hydrogeology. And this here is the river. The color is just too similar anyway. But to notice, it could be with the OSM with the OSM backdrop. But yeah, this is the river here going eastwards, and that's under hydrogeology. So the flow of the water is important. The direction of the flow of water is important because it tells us how the differences in the concentration as we go through a linear mechanism. So in the same way, the geology of the area and the rock interactions are important. It's important to know where the water is coming from and from what environment it's coming from. So I'll move on to the other section, because the idea was to show the interaction of the water with several other related aspects, including the host rock and even the biotic regions. Further context: the aquaculture water. There is fish ponds within the region, so some of the samples were collected from fish ponds, and parameters like ammonium and ammonium ions, and the nitrates were monitored as well to notice, and the dissolved oxygen were monitored to notice the differences in the health of the ponds. So all this data in the end is aggregated to form a universal water quality index, like an overall water quality index, for which describes the state of the water to decision makers so that actions can be taken. There is even a whole system that's supposed to send out emails when the email alerts when we connect it to sensors, which will then send back data. So I just wanted to disclose that this is part of a larger thing, and it's collecting different water quality uses, which are supposed to give out information to relevant stakeholders on the status of the water in the region. So I'll now move on to the geology, which will bring us to describe a profile mechanism as well. So allow me to remove the layer under hydrogeology. I'll just get rid of that layer and leave the contours right there. So under geology, there's a plot of ions and the geology as itself, and the faults as well. So the occurrence of the faults coincides with the origin of the stream, as well as the occurrence of a fissure which brings out water when you are traveling to Livingstonia on the road. So you can see there's a road down here next to the fault, and people who have been to Livingstonia through this Golodi Road will always tell you about a place called Holy Water, where water flows out of a rock. I'm not certain if it was one of the places Moses struck on his way to Canaan, but it's a perennial discharge that never dries out. Even during the dry season, there's water flow within the holy water fissure, which is around here. So this is close to some of the evidence of the fissure, and water flows down this direction and intercepts the road to Livingstonia. So This fault, though on the quaternary aquifer, which is in a sedimentary region, is evidence of it's actually supposed to be within the next region here. I strongly believe, because it is what seems it's actually within the fractured basement region. But if we go back to the hydrogeology, so the data from different sources is fusing very well to make sense of the region. So furthermore, the geology shows that from here, for the sake of the geophysics and other parameters, I'll use the hill shaders again for contrasting purposes. So we have now these regions here within on the key here. The white area is calcareous siltstone. In between is yellow mudstones, and eastward, where the water is coming from, we have a garnetiferous gneiss, which is a rock comprised of garnets as well as iron in the basement region of the country. So it's a very hard rock with which connects to the Nika region as well, which is basically part of the Nika geological distribution. And most of these other rock formations are sedimentary, and especially the siltstones as well as the mudstones. So the whole region is described as a sedimentary region. It's a sedimentary basin, and yeah, it's there's this particular distribution of mineralizations. So in the water quality, you should expect to look into the concentration of calcium and iron as a means of assessing the relationship with the geological occurrences. So having a garnetiferous occurrence on this end and a calcareous siltstone on this end, you should expect to have higher calcium concentration on this region and lower calcium concentration in this region, because this is a calcium-based rock formation. And geological reports of the area further agree that the region is dolomitic limestone, or the siltstones as that dolomitic. So the ratio of magnesium to calcium is high. So anyway, we can now look at the ionic distribution to give us a picture of this relationship. And now we're using calcium. There's these dark dots, and and you can see the darker the dot, the lesser the calcium concentration. So 0.7 in this region is less. 1.3 in this region means more calcium. The same applies to other ionic distributions that were visualized in the area. They show that the water data agrees with the rock formation data, and it even goes as far as magnetic data as well. So we tested an experimental magnetometer in the area, and we obtained data that also corroborated with the government aeromagnetic survey in the area, which was done in 5 to 6 years ago. So here's the plot of the aeromagnetic data, which we collected using our magnetometer. And it also shows that this region has a higher magnetic TMI, a higher total magnetic intensity, which agrees with the fact that the rock formation on this same region has high iron concentrations, being a granodiferous rock. And the magnetic anomaly in this region is lower because there's mudstones within the area and calcareous siltstones at the center. So we can see from the geological distribution that there is an interplay between these factors, and they have an influence on the water quality. I went ahead to also do a bit of biological data, biodiversity data. Of course, this only covers this was done using Sentinel. It only covers the vegetation for now. So allow me to move to bottom. So yeah, we can see from the normalized difference vegetative index the occurrence of the vegetation, and it is a good and also a measure of the water, the concentration of water within the same region, because catchment areas are predominantly vegetated. So having this and NTVI allowed us to also to understand the catchment dynamics and see which parts are likely to be affected by upland runoff. And this gave us a picture of the ammonium distributions, even the nitrates at the bottom there. So I'll now demonstrate the profiling procedure, and I'm using a tool called QProf. I'll quickly run this for 5 minutes and then demonstrate the one of the exports of the map. So yeah, Stack API browser is how I got the spectral data to analyze the vegetative density. QProf is what we're using to now profile the region. So I define quickly source DEMs. We use the one from JAXA, and I'll digitize a line to show the profile. We won't use the river line because that's clear. We've seen that using the we have seen that area using the topographical dynamics. But now we'll draw a line from this side using the digitized digitized line. So yeah, we'll move from there to the eastern side, southeast, and we'll read source data. It's been read, calculate profile statistics, and we'll generate a topographic profile, which will filter height, and there we go. We can see now we have a profile showing the elevation dynamics. And as you can see, as I said, this region in the center is a plateau, and as you can see, it's very gentle as compared to the northwestern side of the region. So to show the difference, and you can use this tool to even show polygon transfer from polygon data, crop data, which I'll do using the geological intersect polygon layer, and I'll choose watershed geology, and we'll move on to use I can use the watershed hydrogeology, and we'll use the aquifer type and define polygon style. Okay, and we'll intersect. So now we can see that from the other region, we have fractured basement aquifer, the quaternary aquifer, and the distribution goes on and on. So this profile tool can be reported using can be, you can also, using Inkscape, you can also report structures which can be informed by the structural geology, which can be informed by the faults and other structural aspects. Finally, all this data was exported in very beautiful maps, which visualized the relevant data, and we used the QGIS print composer. So I'll just show you one of the print composer screens, and I think we can move on to questions. Layouts, geology. So yeah, that was one of the maps for plotting the map exports, plotting the TMI, mineralogy, calcium concentrations. And you can see from here, we have calcium distributions. And this location that's highest is actually here, meaning is actually here. And meaning that this region is actually predominantly calcium as compared to the other regions where iron is likely to be higher. To do this, we used Plotly, Data Plotly, a plugin, a QGIS plugin as well, and several other composed screens were also made for the sake of visualizing data that was interpolated from the same. The data will be sent out in a cloud optimized format. The geotiffs will be sent out in a cloud optimized format to the web platform that is being used to monitor the water quality of large areas. So the interpolated data, or the TIFFs, will be on a web map, which is hosted online. If anybody is interested, they can reach out. I can give them access to some of the prototypes. At this point, I would like to just show my gratitude for your time. I think we can move on to questions or comments.
Awesome. Thanks so much, Chimango. I think this is fascinating because it shows how often projects are so multidisciplinary. You know, you can see the layers in here. There's geological stuff, there's water stuff, there's magnetic stuff. You know, it's very multidisciplinary, but pulled together in such a great way that it, you know, optimizes the information you can show in one diagram and in one map. And then adding that together with data plotly, I think, is very clever because you can then, you know, easily see the metrics associated with the map. So I think this is a fantastic multidisciplinary project. I'm really interested to see the online maps. So I am one of the people on that list. Please send me the prototypes. Quite interested to know sort of a bit of the background about that and how the data is going to be, you know, used and applied in sort of managing water strategy in Malawi, as well as perhaps tracking changes in the water quality over time. I think that'll also be a really interesting thing to just, you know, see. So as far as questions go, on the live chat, there's no questions. There's just a couple of people saying hi and that this was a fantastic and very interesting presentation. I don't know, does anyone in the room have any questions at this time? A lot of people say they like your hill shade.
Thank you. I made it myself.
Oh, brilliant stuff. All right. So while people are gathering their thoughts about the general overall sort of outputs of this project, I just see some people saying interesting stuff on here. So I want to ask, in general, the big picture of this project, the outputs of your mapping and your work on this, what is it adding to, because you said there's an online, a cloud optimized platform for this kind of information. But long term, is this for managing water strategy in Malawi? Is it for decision making? What is the sort of end goal of this?
That's a good question. The end goal is to manage water strategy, and also reduce complexity such that non-technical users can understand the state of water quality without having to understand what calcium is or what calcareous siltstones are and all those interactions. So in as much as I've displayed, this displays some of the underlying complexities of water dynamics. It surely, the end goal is to summarize the water quality in such a way that decision makers can track pollution. And in the case of mine, there's several mines within the region, coal mines. In the case of mining, mining activity can cause acid discharge, and the moment the pH drops to a certain threshold level, which the Malawi Bureau of Standards has set for certain water sources, the system is supposed to send an alert to summarize that the water is currently bad based on these parameters, and it would be up to the users to dive deeper into why that's the case and maybe all that. But it's for rapid decision making such that rapid action can be taken in the case of harmful pollutants or any other things that might endanger human life and aquatic ecosystems as well.
Awesome.
I don't know if that answers your question.
No, absolutely. That's, I do a lot of work in South Africa with the freshwater biodiversity system, so FBIS. And, this kind of information, the water turbidity, the total dissolved solids, all that sort of thing, is so meaningful in, biodiversity management as well, the ecological side of things. So I'm quite interested in that side of things, less so drinking water, although that is vital, of course. But this would be such useful information for a whole range of decision-making platforms and systems. I'm quite interested to see.
That's true. Actually, Malawi Bureau of Standards doesn't have ecological standards for currently, and I'm hoping that the final published version of this will also make sure that is part of the standardization system. However, I just got interested with your mention of South African water affairs. I actually used the standards from South Africa for this study because I used dwarf standards, Department of Water Affairs. So quite interesting you mentioned that.
No, brilliant stuff. All right. Anyone in the room got any questions? I see there are quite a few people here. Please feel free to come on mic and ask your questions. Or write them in the chat. I'm quite happy to do that as well. And then just on the live chat, there are a whole bunch of people just coming in and saying greetings. I see Mafuza Maya says hello. Eunice says hello, etc. So a lot of people supporting this talk and are really interested in the subject matter. Absolutely awesome. Thank you for everyone who is writing in and getting involved. I then don't think there are any other questions. So if you have any final sentiments, Chimango, let us know.
All right. I'm just grateful for the time. This is my first time to present on QGIS OpenTerra, and I think it was really great interacting with all you. And also, you can find me on Twitter, Chimango Chisuo. If you need if you want to take a look at any of my similar work. So
just remind us of your Twitter handle there again.
It's I'm going to type it in the chat also, at Chisuo Chimango. Yeah, Chisuo Chimango. Or
that is brilliant. Thank you. So definitely pop onto Twitter and show Chimango some love and just check out all of the amazing work. And this is very technical, multidisciplinary work. And I'm always really impressed to see this kind of work happening in QGIS. You know, often we have sessions that are, you know, how to style things and how to make a nice map on some data, etc. Whereas I love to see work that's really, you know, making a difference and contributing to, you know, governmental standards and contributing towards creating, you know, a better future for people in general, particularly with water, because we know that in the future, water is going to be such a scarce resource, especially in Africa. I know in South Africa, that's, of course, a water scarce country. It's very topical at the moment. Anything to do with water and water quality management is vital. So this has been such a fantastic session. I really appreciate your time, Chimango. And yeah, thank you for everyone who joined the QGIS Open Day. This is the last session for the day. Of course, the next QGIS Open Day will be the last Friday of next month, and I will see everyone then. Thank you, everyone, for joining us. Alrighty, I have ended the stream. We are no longer